Hey everyone, welcome back to my channel. I hope you all are doing awesome. So in this video we'll talk about like C# provide multiple ways to run your code asynchronously, like your threads, task and async await. So like most of us get confused like are all the same thing, or like when should we use one over another, and what is the difference between the task dot wait all and await task dot when all. So in this particular video we'll talk about these three like methods to run your code asynchronously. So without any further ado, let's start with the video. Let me quickly share my screen and see you there. Hey, hello, what's up? I hope my screen is visible. Okay, just give me a sec. Cool. So yeah, so as I mentioned, in this video we'll talk about like C# provide us the multiple ways to run code asynchronously. Sorry yaar, thoda gala kharab hai. That is your thread, tasks and your async await. So like in this video also we'll talk about what is the difference between the task dot wait all and await task dot when all. Okay, and we'll also see the like live examples of these. Okay, so threads, I would say like this is the most foundational unit of execution. Like in simple, when you run your program, like the main class we have, that's run on the main thread. Okay, that is also a thread. But if you also want to like run parallel threads, so you can create worker threads over there. So how you can do that? Let me show you here. Sorry, because यहाँ पे जो अपना कोपायलट है और इंटेलिजेंस भाई क्या ऐसे रिकमेंडेशन देता है, तो यहाँ से कोड करना चाहिए या विजुअल स्टूडियो से करना चाहिए? व्हाट डू यू थिंक? यहाँ से कर लेते हैं, थोड़ा इजी हो जाएगा बिकॉज सिंटेक्स तो मुझे याद है. पब्लिक क्लास, देखो भाई पूरा का पूरा कोड दे दिया भाई ने. ठीक है, तो एक बार फटाफट से इसको चेक कर ले. हाँ. अगर आपको नहीं पता कि ये जो फाइल है सॉरी, अगर आपको नहीं पता कि ये फाइल्स कैसे काम कर रही हैं, if you don't know like how I'm just running a single CS file here, so you can go and check it out. I already have a video for this on my channel, like .NET 10 features. You can go and check it out there. This is one of the feature. Okay, so we have hello world. Rather I would like to change this to main method executed, and this is working. Yes. So here we can create one thread, t is equal to new thread. Okay, so this way we can create a new thread, our own thread, custom thread. You can like whatever you want to assign to this thread, or you want to perform some job using this thread, you can do that. It's all up to you. I'm just here showing you a basic example. Okay, so this is a one. So but for running this thread you have to start this thread. Okay, so if I compile this again, main thread executed, hello from the thread. Okay, so this is our custom thread and this is our main thread. But if we'll see the order, although they both are running on the different threads, this is another thread and this is another thread. This is running on the main thread and this is on our custom thread. But why we are getting the main method executed first and hello from the thread is at the last? Yeah, this is not the sequential way. Or if you are thinking like we have wrote in order, first thread would be executed, it's not like that. They are running independently. But yeah, if you want like your main thread should not be terminated or executed completely until all the threads are completed. So for that what you can do, you can here say t.join. So it will block the like your main thread to be terminated, it will wait here. So I think I should write one line as well here. I can write here, yes, as you can see, waiting for the main method is waiting for the thread to complete. So now you will see the difference. Now our main method is waiting for the thread to complete. Hello from the thread. Now main method executed. But if you will just comment it out this line, then you will see your main method is not waiting. It was waiting, but it got terminated or executed completely. So for that we have to join this. But I would say there are some like pitfalls for using this thread. What are those? So you can see here, threads are expensive to create. Yes, obviously. Too many can hurt performance. Yeah. Although you have to manage lifecycle manually. Join about not recommended. Like here we are using t.join. So we have to manage this lifecycle of a thread manually. Okay. And this is not recommended. So what we can do? We can move to the tasks. So task, I would say the higher level abstraction. As you can see here, higher level abstraction built on the thread pool. You know what is thread pool? Thread pool is responsible for doing all the things, thread lifecycle. But this is the higher level abstraction on the thread pool. So can you think like how powerful? So now can you think that how powerful this is? So yeah, automatically reuses worker threads and provides features like cancellation, continuations and exception handling. Okay. So let's see the example. Let me quickly remove these all. Okay. So first we will create task. Our task is equal to task.run. No, we don't want to await. And we'll say here, hey from task 1, or let me give it a name as task 1. Cool. अरे रुक जाओ भाई, ऐसे पढ़ने भी नहीं देते हैं भाई, क्या है? No, I don't need. So here we can just say our task 1 dot. No, I already we are running the task. भाई ये कोड लिखने ही नहीं देगा मुझे ऐसे लगता है. Main thread executed. Okay. Now if we run this, so what we get? Main thread executed, hey from task 1. Okay, so we have written the same code, we are just running the task here. No यार, I don't want to async. ये चीटिंग है यार, यहाँ नहीं कर रहा मैं, हम यहाँ लिखेंगे कोड. ओके, लिखना ही नहीं देता यार कोड. और यहाँ पे हम ये इसका इंटेलिजेंस इतना नहीं है, तो हम सिंपली एक टास्क बनाएंगे. ओके, ये भी दे रहा है, मैं कहाँ जाऊँ? ठीक है, तो अभी के लिए हम इतना रखते हैं. टास्क कंप्लीटेड. और हमने क्या किया था, टास्क रन हो रहा है. अब हमें एक बस लाइन चाहिए, मेन थ्रेड executed successfully, not successfully, main thread executed. So let me run this. Now can you see here, main thread executed and task completed. Now the same way we had with the thread. Okay, So what we did there, we used t dot join there. Okay, so here what we can do, we can say task dot wait. Yeah, task dot wait, and if we run this again, then our main thread will wait, because we can write here as well, main thread is waiting for task to complete. We can again run this, main thread is waiting, task completed, main thread executed, or I can say completed. Cool. Now this was for the one. Suppose I have one more thread, not actually thread, the task I would say, and here I would say task 1, task 2. Now task 2 completed, now main thread is waiting for task 1 to complete, task 1 completed, main thread completed. But don't you think so, like our main thread should also be wait for task 2 to be completed before just like execution? So for that you have to not do task dot wait, you have to use task dot wait all, and inside that you have to specify all the threads for which you want to block your main thread or the calling thread. Now your calling thread, like the main thread, has been blocked until all the tasks I have for which I am waiting has not been completed, so you cannot complete your main thread. That is blocked as of now. Okay, so main thread is waiting, task 2 completed, task 1 completed, and main thread completed at the end. But here is a catch, it is blocking our main thread. So instead, because as of now we are working on console, so it's harmless. I think I have written something on this as well. Yeah, like this is task. Yeah, the problem with task.waitAll blocks the calling thread. As I told you, it blocks the calling thread. In a console app, that's harmless. As we are working on the console app, it's harmless. It will not harm us. But in a UI app, it freezes the interface. Like your UI would be unresponsive for that time it is waiting. So in ASP.NET, it wastes server threads and hurts scalability. Exactly. So what is the solution of that? We have one more thing provided in C#, which is your async await. Yes, exactly. So async await is like not the new threading model. It's just a synthetic sugar that lets us write asynchronous non-blocking code in a clean way. So how we can do that? So let me show you here. Okay, so here we will use async, and for the simulation we can call here your task.delay, and same for this task we can use async. Cool. Now here we cannot use wait all, we have to use here when all, and we have to use wait. Cool. It is showing error, a task object in array have completed, create a task that will complete a task that represents completion of all the supplied tasks. The await operator cannot be used within an async method. Consider marking this method with async modifier and change it the type to task. Okay, oh my bad. So we can change this to the async, and we can, cool. So let me run this here. So can you see, like our main thread is waiting and task 2 completed, task 1 completed, order could be anything, and this is like decided by your OS scheduler. Then your main thread completed. If you observe here, our main thread was free. it was not like blocked, but you would say like the output is identical as well with the your task.wait all. You will not see the real difference here, but once you will integrate with the UI or the servers, then you will see like how this is making the difference. Okay, so earlier we also talked about like in the beginning, I'll show you something. So this is time for showing you something. We can keep here, not exactly here, and here. So let me quickly run this application. I don't want these. I'm not looking for this. Just go to debug here, go to Windows and call the parallel stacks. Did you know that? So here, this is our main thread, program main. This is calling some external code, and this has like two tasks. One is your task 1. Now control is coming to this worker in line 7. As you can see on our line 7, it hits the breakpoint. So in line 7 we have, this is our thread. Okay, so let me continue with this. Now the control came to the another worker thread, and this is lock owned by a thread, and this is the another stack, and this is basically under coming, like I mentioned, this is the higher level abstraction on built in on your thread pool. So this is the another thread, and once I complete the execution, now you can see our main program is here, the main thread, and this is the worker node. And let me finish this, and you are getting your output. You can watch this, and the same way you can watch your thread as well. So this was the like one thing you can see, like how your threads are flowing, how the control moves from one to the another. So initially it's on the 0 0. Let me continue. As you can see, it's working and it's waiting for 2 seconds, and now the control is here on the your 0 1, which was the another one. So let me continue this, and now the control will come to your main thread, because it was saying I am free, I'm doing anything. Once you are done with all of your tasks, just let me know, I'll resume my execution. So this is just resuming its execution. Okay, so yeah, that's all for this video. I hope you found this video helpful or useful. So if so, then don't forget to like, subscribe or share. Oh, just hold on, we have left with the like conclusion. I forgot, I have prepared this as well. Thread low level, full control but expensive. Task higher level, use thread pool, better for parallel workloads. Async await, make async code clean, non-blocking, perfect for I operations. Okay, so yeah, now I can say that's all for this video. If you found this video helpful or useful, then don't forget to like, subscribe or share. I'll see you in the next video. Till then, keep learning, keep growing. Bye bye.